Page 20 of the North Carolina problems. Problem 31, so to speak. They're all over the place. So, Kevin's teacher gave him the following pieces of cardboard. Which polyhedron can Kevin build with some or all of these pieces? All right. Well, if I wanted to build a cube, I would need 6 squares to build a cube, because a cube, squares are great for cubes. But the problem is, there's 1, 2, 3, and then underneath, then over there, and then back behind there. You need 6 of them, so I can't do a cube. I can't really do a pyramid because I have only 2 triangles. So I'm definitely going to need 4 sides or 3 sides, not quite sure yet. So let's try using these for the bases. So I'm going to have a triangle underneath. Then I'm going to put one of the squares here, and then one of the other squares lines up right there, and there's another square. And then I put the other triangle on top. Aha, that's a nice shape that I can make. Did I use all the pieces? No, I had 1 extra square. Now, what kind of shape is this? If it was, if the sides were pyramids, then, if the sides were triangles, it would be a pyramid. But the bases are triangles. So the sides are actually squares, which count as rectangles, by the way. And the rectangles make this a prism. The easiest way to tell if something is a prism is if the sides are rectangles or squared. Which ones are the sides? The ones that aren't the bases. You can only have 2 bases. All right? And if it's a pyramid, sides are triangles. So we know that this is a prism, and in fact it's a triangular prism. Next problem, a container in the shape of a rectangular prism, so we don't really know. It looks like an aquarium, I betcha. All right. We don't really know how big it is. It says it measures 20 centimeters. Well, we do. Or let me make that 30 by 20. And that the height is 15 centimeters. The container's already got some water in it. All right, fine enough. The container is partially filled. A student adds more water to the container and notes that the water level rises 2.5 centimeters. So he adds some extra water. All this water right here. And he notices that it goes up 2.5 centimeters. Well, all I have to do is calculate the volume of that section. So volume is big B times H. So it'll be 20 times 30, because that's the base, times 2.5. 20 times 30 is 600 times 2.5. And that should be 1,500 cubic centimeters, which is A.